Good morning. This week's episode of the Chem Scoop is between Brittany
and River.
So we're doing a Q&A today. Our first question is for River. Can you define potential energy?
When I think of potential energy, I think of like staying still, so like sitting in line or in class, rather than moving around a whole bunch. Our second question is for Brittany. How would you define kinetic energy?
So for me, kinetic energy is just moving around. So whether it be you're walking a hallway, you're playing a sport, you're rolling a ball down a hill with your siblings or something. Okay, so our next question is for River. It is, what is your definition of the law of conservation of energy?
So the way I think about it, energy can't be created or destroyed, as most people know, but it can be transformed into a different type of energy, so like potential or kinetic energy. So it kind of goes hand in hand with what we were talking about.
Okay, I'm asking another question. What's the difference between exothermic and endothermic reactions?
The main differences are mainly, wow, amazing words. So for endothermic, the energy that is needed to break is greater than the energy that is freed when it is formed. So it is absorbing more energy than it is giving. So it will be cold. Another thing is uh, it transfers the surrounding kinetic energy into the system as potential energy. While exothermic, the energy needed to break something is less than the energy freed when formed. So it is giving energy and losing energy. So it is hot because it is losing heat energy. Another kind of flip flop of what endothermic is, it transfers energy from the potential energy into the surroundings as kinetic energy. And some examples for endothermic is melting ice and photosynthesis. Exothermic is like melting sugar or burning coal.
Okay, one of the other questions we have is for River. What is a phase change diagram?
So, a phase change diagram is a little complicated, but it's exactly what it sounds like. So, it's a diagram that shows different phase changes. It has a line showing where the water is melting, where it's evaporating, where it's freezing, and then there's separate sections that shows like where it's frozen, where it's solid, where it's liquid, and where it is gas. And then where all of the lines meet is called the triple point. Our next question is for Brittany. What are the variables and formulas of calorimetry?
So there are three variables, and one of them, or to start us off, is Q. Q is the heat absorbed, M is the mass of the substance, C is the capacity of the substance, and T is change in temperature. So the formula for it is Q equals NC triangle T, capital T.
And then our last question is, how would you define specific heat?
So specific heat is the amount of energy needed to raise the temp of 1 gram of substance by 1 degree Celsius. And one extra bonus question. Someone was also asking about heating and cooling curves. Do you know anything about that?
I know a little bit. So I know for endothermic, it's basically just a graph of what that would look like visualized. So lots of energy comes in, but not a lot comes out. And then for exothermic, it's the opposite. Lots of energy, not a lot of energy comes in, but a lot of energy comes out. So it's basically just endothermic and exothermic, just visualized.
Just displayed. All right, so that is all the questions we have today. Join us next week for another episode of the Chem Scoop with Brittany
And River.
Bye.
Bye.